All right, so today we're going to talk about first the zeros of your polynomial. So the zeros of a polynomial, we also say that is their roots. It is their solution. It is also where it crosses what? Good. All right. So we're going to start off by reminding you that we can factor to find zeros, and that we can set those wonderful factors equal to 0 and solve. All right? Does anybody remember what we called that? It was called the zero product property. So here is example number 1. Find the zeros by factoring. All right. So let's say I have y equals how about let's start off with an easy one. X to the third minus 16x. Take an x out, exactly. Thank you. We're going to undistribute an x. Leaves us with x squared minus 16. It is the difference of squares. So we have x plus 4 and x minus 4. All right. Now if we set each of those factors with an x in it equal to 0, we get x equals 0, x equals negative 4, and x equals positive 4. Those are the 3 places where this crosses the x-axis. So let's mark those on an x-axis for a second here. So it's going to cross here at 0, at 1, 2, 3, negative 4 on the left. I almost said right, on the left. And positive 4 on the right. It's going to cross through that many times. Is this an odd or even function? It's an odd function, right? So we know that their end behaviors are going to go in opposite directions. We also know this has to turn how many times? It's got to turn twice, right? So, and since this starts off as positive, we know that the end behavior on the left goes to negative infinity, and on the right goes to positive infinity. And then if it's turning twice, it's going to turn once here, cross through our other 0, and come right back up. So we're going to do a little sketching of those today too. When we're sketching them though, I want to just remind you that I'm not too concerned about how high this goes up or how low that goes down, because we're not really talking about the max and min. I want to make sure we get the number of turns, whether it crosses through the axis. Remind me again, when does it bounce off the x-axis? I know you guys know this. Yes, when it's an even multiplicity, it's going to bounce off the x-axis. So let's try one that looks something like that. So here's example number 2. Oops. Find, maybe, the zeros of the function and sketch. All right, and let's go with y equals x to the third plus 4x squared plus 4x. All right, so first of all, to find the zeros, we're going to factor. What can I take out of everything? An x, beautiful. If I take an x out, we're left with x squared plus 4x plus 4. Then I've got a quadratic left to factor that. I'm going to draw myself a little x over here. 4 on top, 4 on the bottom. What are my sides? 2 and 2, right? So this is x times x plus 2 times x plus 2. Or we can write this as y equals x times x plus 2 squared, right? Okay, so my first x, if I want to find the 0, I said x equal to 0, and I get x equals 0. The next one, x plus 2, x equals negative 2. But because it's got that squared on it, there's more than one negative 2 in here. So we call this its multiplicity of 2. All right, so now let's sketch it. So we know it's going to cross through, or we're going to go to 0. We also have it at negative 2. Now again, is this an odd or even function? Odd. Is it positive or negative? Good. Okay. So since it's positive, the ends are going in opposite directions, right? And that means this one's going to negative infinity, and this one's going to positive infinity. Now, since there's a multiplicity of 2 at negative 2, that means this is going to bounce off there and then cross through 0. You guys remember doing this, right? Okay. Peter, did you do this online? No? Okay. Multiplicities? Okay. Okay, so let's practice a couple more. So I'm sure we only did a couple of them. We talked about multiplicities all the time. We talked about what they do in the graph, but we probably only sketched a couple. Because what are we normally going to do? We're going to grab our graphing calculator, aren't we? I mean, and we probably talked about it that way as well. So let's do another one. Example number 3. Let's try this. How about I want you to sketch the graph. And let's do y equals 3x times by x plus 4 squared times by x minus 1. I don't know. All right, so I've already got this one factored for us, right? In the first one, I have x equals what as our 0? 0. In this one, I have x equals, good, multiplicity of 2. And how about my last one? X equals 1. Awesome. All right, so I'm going to graph this. I'm going to plot these points. I have 1, 2, 3, 4 to the left. I have 0, and I have x equals 1. All right. So tell me about this function. Since I wrote it in factored form, is this odd or even? It is even. Exactly. If you count your x's up, right, we have 1 here, x squared here, and another x, so it's x to the 4th power. Okay, is this positive or negative? So that means that the ends are both pointing towards positive infinity, right? Okay, so we know if it is an odd multiplicity, it's got to cross through those points. So this has to cross through 0 and it has to cross through 1. So we know it's doing this, right? And it's going to bounce off of negative 4. So this graph comes off of negative 4, crosses through 0, and crosses through 1. Still looks like our W, it's just a little off kilter, I guess, right? A little wonky, but you know. All right, one more. Let's graph this one. How about y equals x squared times by x minus 5 to the 3rd. Oops. It's an odd power. What else do we know? We know this is odd. We know it's positive. Okay, so our ends are going in opposite directions. On the left, it's going to negative infinity. On the right, it's going to positive infinity. Yes. Yep. Okay, what else do we know? Okay, so what's this first one, Shelby? 0, and what's its multiplicity? Good. Maybe, if I can write. Good, and x equals 5. What's its multiplicity? Good, multiplicity is 3. So this one is an even multiplicity, so this is going to bounce, right? This one is an odd multiplicity, so it's going to cross through. Spell through right. There we go. All right, let's check it out. So I'm going to graph this. We know we have at 0. It's going to bounce off of there. We know it's going to cross through at 5. 1, 2, 3, 4, 5. It's crossing through here. It is odd, so I know that this one's got to go that direction. And I know this one's got to go that direction. I know it's going to bounce off. I know this is crossing through. But here's what we don't really know. What's going on in there, right? We don't really know what's going on in here. It could just be 1 minimum. Or, because this is to the 5th power, it could turn a total of how many times? Could turn a total of 4 times, right? So here's 1. We could turn, and then turn 1 more. It could do a lot of different things in there. So grab your graphing calculator for me. You can just put this in as x squared times x minus 5 to the 3rd. I better grab one too. And let's see what it does in that little section there. Go to your window. Yeah, go negative 10, 10, negative 10, and 10. So yeah, if you look, like mine is set at negative 10, 10, and most of my graph is missing at the bottom. Right? You can see the whole thing? Awesome. So let's do that. Everybody go ahead and go on the y-axis. Is the only one that's set that way, right? Okay. On your y-axis, go ahead and change your y to negative 200 to positive 200. See what it looks like then. So it kind of comes down. Whoops. Kind of comes down. Looks like it turns and then turns and goes up. All right. So does everybody agree it kind of looks like this? Everybody get kind of the same thing? All right. So we have 1 turn. We have 2 turns. We have 3 turns. We have 4 turns. And up it goes. Does that make sense? With our exponents. It does. All right. So here's the deal before I keep going to the next section. On your homework today, 7 and 8, it's just asking you to locate the extreme in your calculator, which we've done 100 times, so I know you can do that without me having to go over it, right? Max and mins, left bound, right bound, right? Okay. The next section, 30 through 60, we're doing multiples of 3. The first few, you are finding exactly what we're doing here. You're finding the zeros and you're sketching it. No big deal, right? Okay, so let's move on to the next part, the next wonderful part. Am I on 4? Yes, 4? Okay. All right. This time I want you to write the polynomial from the zeros. And if I go ahead and tell you that your zeros are at x equals 3, Negative 4 and 6. So first thing we need to do is take those zeros and put them back into our factors, right? So we actually have x minus 3, if it's a positive 3. X plus 4, since it's a negative 4 is your answer. And we have x minus 6. For those of you that aren't sure where that's coming from, remember these are your zeros. So if I wanted to get this set equal to 0, I would move 3 over, and I'd x minus 3 equals 0. That's why it's those numbers, right, Matthias? Okay. All right, so now if we're going to write the polynomial, what we need to do is multiply 2 of these together, get a quadratic, and then multiply the quadratic times x minus 6. To multiply those together, we like to use the box. So we're going to do a little box first. X minus 3 times x plus 4. All right, x times x is x squared. X times negative 3 is negative 3x. X times 4 is 4x. Negative 3 times 4 is negative 12. So the quadratic we have right now is x squared. Adding our diagonal together, we have 1x and minus 12. Now we're going to go ahead and multiply that times our x minus 6. So we're going to do one more box. All right, x times x squared is x to the third. X times x is x squared. X times negative 12 is negative 12x. All right, x squared times negative 6 is negative 6x squared. Negative 6 times x is negative 6x. And negative 6 times negative 12 is positive. Perfect. All right, so we have x to the third. Negative 6x squared and positive x squared is negative 5x squared. Good. Minus 18x plus 72. Now remember, this is a polynomial, so what do I really want to set it equal to? Well, I'm writing the equation for the polynomial. How about y? Let's go y or f of x. I'm okay either way. Okay? Any question on finding those polynomials? When did we have special ones? Okay. Well, what if I told you we have zeros at, let's do square root 3 and I. Let's just throw an I in there. Okay, yep. I squared is negative 1. But when we have a 0 at square root 3, we also have a 0 at negative square root 3. If we have a 0 at I, we also have a 0 at negative I. So although we have zeros at square root 3 and I, that also means that we have them at the positive and negative. So anytime you have a radical, which I is a radical, right, you have positive and negative. Do we remember how to put these into the box? All right, so let's start with doing these two. So really we're going to do x minus square root 3, x plus square root 3. We have x minus I, and we have x plus I. Okay. I also want to remind you we wanted to multiply the two that are the same together. We're going to multiply these two together, and then, of course, we're going to take their results and put those together. Okay? All right, so here we go. So 3 boxes. Won't get any bigger than this today, I promise. We have x minus square root 3. We have x plus square root 3. So x times x is x squared. X times negative square root 3 is negative x square root 3. X times positive square root 3 is x square root 3. And negative square root 3 times positive square root 3 is negative 3. Perfect. All right. What do you notice about the diagonal on any one of these where you have its positive and negative? Yes, it's going to cancel every time. So really we have x squared minus 3 for our first one. Let's do our i's. We have x minus I and x plus I. X times x is x squared. X times negative I is negative ix. X times I is positive ix. Negative I times positive I is negative I squared. Remind me again, what's I squared? So what is this whole corner going to become? Positive 1, right? All right, so we have x squared plus 1, because again, our diagonal is going to cancel out. Exactly. So our last little box we're going to have to do today, we have x squared minus 3 times x squared plus 1. X squared times x squared is x to the 4th. X squared times negative 3 is negative 3x squared. X squared times 1 is x squared, and 1 times negative 3, negative 3. So we end up with y equals x to the 4th, x squared and negative 3x squared, negative 2x squared, and then minus 3. So this has all come back to us, right? Peter, you doing okay? Okay. All right. The last section in your homework, they give you a couple tables, and they ask you to find the cubic regression model. What does the word regression mean you got to do?
Oh, it's a stat.
Yes. So you're going to go list 1, list 2, back into stat, over to calculate, and down to cubic. Yes. Okay, so you guys already know how to do that too, right? Okay. Awesome. So I'm going to go ahead and let you get started. It really is not that many problems. When I say 30 to 60 multiples of 3, it really narrows it. Yeah, it narrows it down.